Every programmable device requires some kind of a software and a programming language to program it. In our case, the Arduino is programmed from the Arduino IDE, or Arduino Integrated Development Environment, based on previous IDEs like processing and wiring, and the programming language is based on C++. Let's begin with installing the IDE. The installation process is rather simple. Head over to the software section on the Arduino website, then click on the version for your operating system, and once the file is downloaded, launch it, and a couple of formalities later, it is ready. For a complete install guide though, click on the link in the video description. Finally, that we are into the IDE, let's program an Arduino. First, let's connect the Arduino to our computer and verify the following things in the IDE. Click on the Tools menu in the toolbar and check if the right device is selected. Just below that, we have the option for ports. This decides the port to which our Arduino is connected to, so all the code we compile is uploaded through it. To ensure that everything is working as expected, we'll load the Blink sketch, and for this, navigate to File, Examples, Basic, and open the Blink program. Click the Upload button on the top left of the IDE, and the status bar at the bottom shows a progress bar as it compiles and uploads your sketch. When the upload is complete, the yellow LED on our Arduino should be blinking once per second. And congratulations, we have just programmed our first Arduino sketch. Let's analyze it to understand the important components. So here's how the code works. Number 1. Comments. The program starts with a multi-line comment. Comments are important for documenting our code. Everything we write between the symbols will not be compiled. Multi-line comments are enclosed by a forward slash and a star, and a single line comment is denoted by double forward slashes. It is used for writing shorter descriptions. Number 2 is variable declaration. Variables are places in the Arduino's memory that hold information. Variables have different types. In this case, an integer variable called LED is being set to the value of 13, the pin that the LED is connected to. Number 3 is setup. It is one of the two functions that must be included in every Arduino program. A function is a piece of code that does a specific task. Code within the curly braces of the setup function is executed only once at the start of the program. This is useful for one-time settings such as setting the direction of pins, initializing interfaces, and so on. Number 4 is pin mode. The Arduino's digital pins can function as inputs or outputs. To configure their direction, the command pin mode is used. This command takes two arguments. The first argument to pin mode is the pin number itself. The second argument sets the direction of the pin, that is input or output. Number 5 is the loop. The second required function in all Arduino programs is void loop. The contents of the loop function repeat forever as long as the Arduino is on. So number 6 is the digital write. It is used to set the state of an output pin. It can set the pin to either 5 volts or 0 volts. The first argument to digital write is the pin we want to control. The second argument is the value we want to set it to, either high or low. Number 7 is delay. This function accepts only one argument, a delay time in milliseconds. When calling delay, the Arduino stops doing anything for the amount of time specified. Number 8 is digital write again. Here, digital write is used to turn the LED off by setting the pin state to low. And the next command, that is delay again, we delay for 1 second to keep the LED in the off state before the loop repeats and switches to the on state again. So that being said, let's look at some advanced functionality. What exactly, you might think, I mean by advanced functionality? The sketch we wrote only allows us to blink the LED at a predefined rate. The sketch is essentially static by nature. But by using a for loop, we can vary the rate of the blinking LED, which makes our program somewhat dynamic, and believe me, it looks more awesome than it sounds. To better understand these concepts, consider what happens in the two passes through the for loop. Number 1, I equals 100. Number 2, the LED is set high and stays high for 100 milliseconds. Number 3, the LED is now set low and stays low for 100 milliseconds. Number 4, at the end of the loop, I is incremented by 100, so it is now 200. Number 5, 200 is less than or equal to 1000, so the loop repeats itself again. Number 6, the LED is set high and stays high for 200 milliseconds. Number 7, the LED is set low again and stays low for 200 milliseconds. Number 8, at the end of the loop, I is incremented by 100, so it is now 300. And number 9, this process repeats until I surpasses 1000 and the outer loop repeats, setting the I value back to 100 and starting the process again. And that was all about basic digital outputs. Thanks for watching. Like this video if you liked it, dislike it if you disliked it. Let me know what you think in the comment section down below, and see you in the next video where I'll be talking about basic analog outputs.